Good day, everyone. I am Benedict Feliciano, your instructor for Lecture 1 entitled Matter and its Measurements. First, I will discuss to you what are the parts or subtopics within this lecture. The first one will be the types of matter, which will be discussed in this video, phases of matter, which will be discussed on the next video, a combination of significant figures and measurements, which will be discussed on the third video, and lastly, dimensional analysis, which will be discussed on the fourth video. Before we proceed to the very first subtopic, I'd like to give a very brief introduction about our sub our field of study, which is chemistry. Chemistry is actually or somewhat rooted or originated from a pseudoscience known as alchemy. And alchemy came from the word alchemia, which is an Arabic word meaning change. So, what is chemistry? Based on the definition I gave to you within the handout that I also gave to you, chemistry is the study of matter, its properties, changes, and interaction with other matter, also with other things in our universe, such as energy. It is also sometimes described as an application of physics because most most concepts or almost every concepts you see in chemistry rooted from physics or follows the laws, models, theories, principles, and rules of physics itself. It is also known as the central science because chemistry, its concepts and applications extends to a lot of field of study. For example, geochemistry, geology, agriculture, food science, NVSci, chemical engineering, material science, nanoscience, nanotechnology, mathematics, nuclear chemistry, and sometimes not only in applied and natural sciences, but also in some parts of social science. For example, geochemistry can be used in archaeology, paleontology, and also in psychology, more like a biochemistry, molecular biology type of chemistry. So, proceeding to our topic, our main topic for today, the types of matter. So within your handout, I made to you a very simple, concise, and comprehensive way to identify what type of matter is being asked given a substance. So this is a schematic diagram that I will teach on how will you use it. So there are three parts. The boxes where the main concepts are being written. The second one are the questions, which will be our guide, and the third one are the answers, which will give us the pathway to which type of matter is being asked. First, let's try an example not within this one. Juice. Is juice homogeneous? The answer is no. So, if we got an answer, we will disregard the other one. So, meaning these four concepts are not already in the choices, meaning these two are the possible answers on what type of matter is juice. Then it is already noted that juice is a I mean a heterogeneous mixture. So moving on, does the Tyndall effect occur in juice? The answer is no, meaning juice is a suspension. So I made to you five simple examples that you can try on and covers all types of matter within the schematic diagram. You may pause this video. I will give you 5 seconds to try it out by yourself and then we will discuss how or what are the types of matter. Okay, I hope you paused this video and tried it out by yourself. So let's continue. Salt water. As we all know, salt water is homogeneous, meaning it is not already a heterogeneous mixture, neither a colloid nor a suspension. Next, can the substance be separated by simple physical techniques? Separating techniques. The answer is yes. By distillation or evaporation, we can extract salt or water from the two. So the answer is salt water is a homogeneous mixture or also known as a solution. Next, is salt homogeneous? Obviously, the answer is yes again. Can the substance be separated by simple physical separating techniques? The answer is no, meaning it is a pure substance. Can the substance be separated by simple chemical techniques? Surprisingly, it is a yes. Salt, just like water, can be separated by one of the most common type of separating techniques in chemical reactions, which is electrolysis. Thus, our answer is salt is a compound. Third one, calcium. Of course, it is very obvious that calcium is homogeneous again. Can it be separated by simple physical separating techniques? Similar to salt, no. We cannot separate calcium by simple physical techniques. Thus, again, it is a pure substance. Can it be separated by simple chemical separating techniques? The answer is no. In fact, calcium can be separated, but it will require a lot of particle physics, more like a particle physics separation technique. Because once you separate calcium, you will be obtaining not elements, but rather subatomic particles, protons, neutrons, electrons, that will be discussed later on in this course. Thus, calcium is an element. Third one, milk. Is milk homogeneous? When we looked at it at the far, it does not look like heterogeneous, thus it may be homogeneous. But the answer is it is not homogeneous. There are some particles, sometimes visible in our eye, that makes it not homogeneous. Thus, it is a heterogeneous mixture. But does the Tyndall effect occur in the milk? The answer is yes. I will give away the answer because we will be discussing what Tyndall effect means. It does. Milk is a colloid. Lastly, similar to milk, Milo is not homogeneous. There are particles that you can see when we left it standing. So it is a heterogeneous mixture. But does the Tyndall effect occur? The answer is no. Thus, Milo is a suspension. So, based on the last two examples, what does Tyndall effect? Tyndall effect is actually a very common phenomenon used to determine if a heterogeneous mixture is a colloid or a suspension. So, what is the concept behind it? When we used a beam of light, such as using a flashlight or any source of light, if we pass through that, if we use that beam of light passing through or traversing through non-colloid mixtures, there will be no scattering of light. Unlike on colloid, there will be a scattering of light. So based on definition, those colloidal particles causes the beam of light, visible light, to scatter while traversing through the mixture. So this is what we will see on a macroscopic scale. On a theoretical representation, these lines, straight lines, yellow lines, represent one photon and its traveling path. Traveling path. So, in a non-colloid, either a solution or suspension, the photon will not be deflected by any particle within that mixture. Unlike on colloids, where colloids are defined as some large particles are suspended evenly, separated evenly in the mixture. Thus, there is a higher probability that any photon passing through will hit a colloid and causes it to traverse and deflect its pathway from a straight line to an angled one, causing it in the effect of scattering. So why does it not happen on suspensions or solutions? Based on definition, solutions acts or behaves as one substance. Thus, there will be no particles that will be deflecting the pathway of the photons. What about suspensions? There are a lot of particles in suspensions because based on definition, those particles will sunk down on the bottom if left standing, meaning there will be no particles that will be blocking within the mixture. Unlike on colloids, it is evenly separated within the mixture. So that ends our first video, and you may now proceed on the next video for the lesson of phases of matter.